All right, so we're going to continue this concept of elimination, and we discussed this with the previous problem. But this problem is going to be set up a little bit differently. If you notice when you look at the two equations, yes, we're trying to eliminate a variable, right, so we can solve for the other. But if you notice here, if I add or subtract these equations together, it's not going to eliminate any of my variables, right? If I add now, negative 2 plus 4 is 2. And if I add right now the y's, I will get 7 plus negative 2y, 7y and negative 2y, which give me 5y. So it doesn't eliminate. I can go ahead and add these or even subtract them, but the problem is it doesn't eliminate a variable, therefore I'm not getting any closer to figuring out what the solution is. All right? So the key here is this is what I want. If I'm going to add the two equations together and use this elimination method, I need to have opposites. So like in the previous example, we had negative 5y and positive 5y. When I add those, they're going to go away. Okay? If I'm going to subtract the two equations, I want the quantities, those x and y terms, to be exactly the same, right? So I want a 4y and a 4y, or a 4x and a 4x, or a 10x and a 10x, okay? So I just have to decide. So what I need to decide at this point is, okay, what variable am I going to eliminate, and how am I going to eliminate it? Am I going to use addition? I'm going to use subtraction. Okay, if you've been in my class, I'm going to strongly encourage that you use addition. Okay, so we don't deal with sign errors. Most sign errors are made with subtraction than they are with addition. Okay, but just know that you can use either method. Okay, so this is what I see when I look at these two. When I look at the two equations, I notice the x terms here. The x terms jump out at me, and I'll tell you why. Because if I want to use addition, and that's what I want to use to eliminate, okay, I need these x terms to be opposite. Right? I've got a negative 2x on top, I've got a 4x on the bottom. And I notice if I double the negative 2x, that'll give me negative 4x, which is the opposite of 4x. Okay. Now, we've got to be careful here. Yeah, if I double this, right, if I double the negative 2x, I get negative 4x, and so that's the opposite of 4x, and it's eliminate. But be careful, though, that we understand what an equation means, right? Look, I can't just double this term without changing everything else here, right? And we know this with solving equations. If I double one side of the equation, I have to double the other, okay? And so that's what we're going to do. Basically what we're going to do is we're going to take this whole top equation, and I'm going to double, right? I'm going to double everything in it. Therefore, keep it balanced and keep it equivalent to its original equation. All right, so when I double this, I will get negative 4x plus 14y equals 10. Right, so I doubled everything in the top, created a new equation, but I accomplished my goal. My x term became negative 4x, which is the opposite of 4x. Now I'm going to copy the bottom equation. And this is what you're going to find, is that sometimes you need to modify one or both of the equations so that you can accomplish this goal of eliminating one of the variables. So we just modified the top. Didn't even have to touch the bottom. Now I'm going to add them. Okay? And you will see now that our x terms, okay, are opposite. And so when I add, those go away. Okay? So I literally get 0 x's, right? And then 14y's plus negative 2y's is positive 12y. And 10 plus 14 is 24. And we know 0x is just 0, and 0 plus 12. So this is just 12y. It just eliminated my x term, right? Remember elimination. Okay? And then our very last step, as I kind of scroll down here, is to divide by 12, and so y equals 2. Y equals 2, right? So when we go over here, we're going to write that. My y value, right, is 2. Okay? So what this is going to tell me is that these two lines, these two linear equations, right, are going to intersect at an ordered pair that has a y value of 2. So they are going to intersect at one location. All right. Now, how do I find the x value? Well, it's the same way we did in the previous video. We're going to take the 2, but this is the y value. and we're going to insert it for y in either of the equations. Okay, and I need you to remember why we can plug it into either one. This is where they're both the same. Remember, we are trying to find the ordered pair that works for both, and they work. The ordered pair that works for both has a y value 2. Okay, so that means 2 will be the y value for in either of the equations. So we can plug it in for either. And it looks like to me, when I look at these, I'd rather plug it into the bottom one. But it doesn't matter either one. So we're going to take 4x, and it's the y value. I'm not plugging in for the x. Minus 2y, 2 times y. Well, y is 2, right, equals 14. See, the y value is 2. That's why I put it there. Right? Negative 2 times 2 is negative 4. Right? And now this becomes a one-variable equation, right, that we're trying to solve. Okay? I'm going to add the 4 over. 14 plus 4 is 18. You guys see how important it is to solve, be able to solve a two-variable equation. It shows up again in this problem, all right? And it showed up again when you were graphing linear equations, right? When we were substituting in for x and to find y. You have to be able to solve a two-variable equation, right? And then we're going to isolate the x by dividing by 4, or you can multiply by the reciprocal, 1/4. 18 divided by 4 is 18/4, okay? Which we could use, right? But 18/4 actually, as a mixed number, 4 divides into 18 4 times, right? 4 times 4 is 16. What's left over? 2 2/4. And what's the same thing as 2/4? 1/2. And so let's use 4.5. Okay. Once again, what this is going to tell me is that if I inserted 4.5 for x and 2 for y into either of these equations, okay, it would give us a true statement. Meaning if I plugged it into the first one, it'd give me 5. If I plugged it into the second one, it'd give me 14. Right? What will we see if we graph these two lines? Right? These two equations. We get two lines that intersected at the point 4.5 2. 4.5 to the right and 2 up. Okay? We cannot forget what this ordered pair means in the context of the graph. If we graphed it, it would intersect at this point right here. Okay? I hope this was helpful.